Hello guys, welcome back to another video of our online course. In this video, we are going to discuss classification of non-traditional processes. Before going to classification, we'll summarize what is meant by manufacturing process and what is meant by non-traditional machining processes. As we know that our manufacturing processes are broadly divided into the two groups. First is the primary manufacturing processes, where basic shape and size is to be provided to the material as per the designer's requirement. In that, casting, forming, powder metallurgy, this kind of process coming. And the second group is the secondary manufacturing process. This group provides the final shape and size with tighter control on the dimension and surface characteristics. This is the second group. Okay, and our material removal process, it belongs to the secondary manufacturing process. Again, this material removal process, it is divided into two groups. First is the conventional machining processes and second is the non-traditional or non-conventional machining processes. In conventional machining process, mostly material is removed in the form of chips by applying the forces on the workpiece with a edge-shaped cutting tool, and that is harder than the workpiece. Okay, so examples of these conventional machining processes are turning, boring, milling, shaping, slotting, also grinding. Now coming to the second group, that is the non-traditional machining processes or manufacturing processes. Now this group is defined as a group of processes that removes excess amount of material by various techniques involving mechanical, thermal, electrical or chemical energy or combination of these energies, but do not use a sharp cutting tool as it needs to be used for the traditional machining processes. Got it? Now examples of this non-traditional machining process are abrasive jet machining, then electric discharge machining, electrochemical machining, laser beam machining, plasma arc machining, ion beam machining. These are the examples. Let us move for the today's topic, that is a classification of non-traditional machining processes. Now these processes are classified according to the source of energy used to generate such machining action. Now there are mainly three groups are there: mechanical, thermal and electrochemical and chemical group. In mechanical energy based processes, erosion of work material is carried out by a high velocity of stream of abrasive or fluids or both. And in thermal energy based processes, thermal energy is applied to a very small portion of the workpiece, which causes removal of the material by fusion or vaporization of the material. Okay, and in electrochemical, it is a reverse of electroplating, where electrochemical dissolution, that is a ionic dissolution, is happening. Okay, this is just a overview of classification. Now we'll go in detail. Now look at in this slide. Our non-conventional processes are divided into the mainly three categories. Okay, first is the mechanical. Under mechanical, we have the different machining processes. In that, abrasive jet machining, water jet machining, abrasive water jet machining, ultrasonic machining. Also, there are some finishing processes are there: abrasive flow finishing, magnetic abrasive finishing. Okay, so these are the mechanical energy based processes. Now second group, thermoelectric group. In that, mainly electric discharge machining, that is EDM, then plasma arc machining, laser beam machining, electron beam machining and ion beam machining. These are the processes belongs to thermoelectric machining process. And the last, that is chemical and electrochemical machining processes. In that, chemical machining comes, then our PCM will come, and mainly electro chemical machining. Okay, so this is a classification. Now let us discuss one by one. Now first that is a mechanical advanced machining processes. Okay, like abrasive jet machining, ultrasonic machining, and water jet machining. Okay, it is developed but with a limited success. Here kinetic energy of either abrasive particle or water jet, it is utilized to remove the material from the workpiece. Abrasive water jet machining also uses kinetic energy of abrasive particle, okay, which is flowing along with the water jet. Also, magnetic abrasive finishing is another process in which magnetic abrasive brush is utilized to reduce the surface irregularities from the pre-machined surfaces. A new machining process, it is called abrasive flow machining, and it is developed recently. However, performance of these processes depend upon the hardness, strength, and other physical and mechanical properties of all the workpiece material. What is really needed is the development of machining method whose performance is unaffected by physical, metallurgical, and mechanical properties of the workpiece. Okay. Thermoelectric methods are the which overcome the drawback of the mechanical processes. Okay, so thermoelectric process as well as electrochemical process are more and more deployed in the material industries. Okay, so let us start the second part, that is a thermal energy based methods. Here the energy is supplied in the form of heat in case of plasma arc machining, and the energy is supplied in the form of light in case of the laser beam machining, and energy is supplied in the form of electron bombardment in case of electron beam machining. Okay, the energy is concentrated on the small area of workpiece, resulting in melting or vaporization and melting both. Plasma arc machining has been identified as a rough machining process. However, laser beam machining and electron beam machining are good enough for making very fine cuts and holes. However, electric discharge machining is a process which is capable of machining of materials economically and accurately. This process is widely used for machining hard and tough material, but electric conductive material should be there. But it is unsuitable for many applications where very good surface finish, low damage to the work surface, and high material removal are the requirement. Thus, mechanical and thermoelectric methods of advanced machining processes also do not offer a satisfactory solution to some of the problems of machining the material which is difficult to machine. Okay, here I have shown the category of thermal non-conventional machining process: EDM, EBM, LBM, plasma beam machining or plasma arc machining, and ion beam machining, and how the material removal rate happens, that is action. Now let us discuss the chemical and electrochemical machining. Now in chemical machining, it is a etching process which has very narrow range of application, mainly because of very low material removal rate and difficulty in finding the suitable etchant for the given work material. On the other hand, electrochemical machining has a very wide field of application. It is controlled anodic dissolution process that yields high material removal rate, which is independent of any physical and mechanical properties of the work material. But work material should be electrical conductive. In this process, there is no tool wear, no residual traces, no thermal damage caused to the workpiece material, and no burr on the machined edge. Also, these advanced machining processes cannot fully replace the conventional machining processes. Also, biochemical machining is a process being developed to the machine a biodegradable plastic, and this process has been very limited application. Okay, though we have the different processes for the machining of the different material, but none of these processes is the best under all machining condition. Some of them can be used only for electric conductive material, while other can be used for both electric conductive and electric non-conductive material, and performance of some of these processes is not very good, while machining like aluminum material having a very high thermal conductivity. Also, these machining processes have their distinct characteristic features, hence selection of appropriate machining process for a given situation or product requirement become very important. Let us highlight about the how to select the process and which process to be used. Okay, so there are the following factors that should be taken care while selecting the process. So first factor is the process capability, then physical parameters, shape to be machined, and properties of the workpiece material to be cut, and the most important, that is economics of the process. So these parameters we have to consider while selecting the different processes for the suitable material. Okay, this is about classification of non-conventional machining or advanced machining processes. Thank you very much. Please subscribe our YouTube channel and follow us on Facebook also. Thank you.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends and don't forget to subscribe to our channel. After subscription, you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.